So a particle is projected from the ground with a velocity of 50.96 at an angle. Now, see that angle? Tan A is 5 over 12. That means an adjacent of 12 and a height of 5. Now, get the hypotenuse, and what do we get? 5, 12, 13, yeah? You will know these off by heart in the end. That when you do Pythagoras theorem, you're going to get 13. Can anybody therefore tell me what cos A is? 12 over 13. Can you now tell me what sine A is? 12 over 13, right? Now we're going to mix up our throwing. Okay, so everybody see the throwing? So how fast are we throwing this again? And this one's going to be 50.96. What? It's the adjacent side, so A, and the other one is 50.96 sine A. Would you be so kind as to, this side of the room here, yeah? I'd like you guys to replace cos A with 12 over 13 and give me the new answer in decimals. This side of the room, which is including Mr. Dalton and Corey, what I'd like you guys to do is I'd like you to do the sine for me. Replace sine with 5 over 13 and multiply it by 50.96. And you guys are now going to tell me what we get. 203? That's not possible. 19.6 for the sine. Okay. And for the cos, has anybody got successful cos done? 50 points. That sounds right. Did you multiply 50 by 96, multiply by 12, divided by 13? What you get? Hey, now. Okay, guys, you looking? Okay, so on its upward path, it just passes over a wall 15.7 meters high. Now, what you're treating this as, you're treating it as a particle, okay? So it just, even though technically its path isn't altered by it, it's so infinitesimally small that it just clears the 14.7. You're not worrying about you're doing assumptions here. You're not worrying about the radius of the particle or anything like that. It's just a simplification approach. It makes it boy. Is that right? And then what else happens in the meantime? It goes up a bit higher, and then what happens? Insurance fire also passes over a wall 18.375. Now, I think I might have messed up my diagram slightly. I probably should have had it. A bit closer like that. So that can be the 14.7, can't it? Now, technically, okay, that second wall could be anywhere. It could be on the way up or the way down. So I have a bit of choice where I want to put this wall. So this wall could be located here. That could be the wall. Or vice versa, I could slide it in such a manner that it's on the way down. Either way, every time it's what goes? 18.37, 5 both times. So does everybody see the model I laid out? Okay, so gonna rub out these ones because we've already used them. And okay, guys, what's phi x? 47.04, your direction in the x direction, yeah? What's phi y? 19.6, it's u plus at, so it's your 19.6 minus your 9.8 t. Your sx, guys. Yeah, It's your speed multiplied by time, no acceleration. Your SY, that's my boy, half of gravity, 4.9 t squared. Okay. Now guys, we're going to start off. Okay. Shouldn't flight also pass over wall distance. Show that there will be no less than. Okay. I wonder if we can get any information. About the on a super passover wall 14.7 high, during flight passover wall 8.7. Showing the second wall must be no less than this, not more than this away from the first one. Okay. What I'm thinking is, I would like to know, see this blue distance on the board? What direction is that in? S, X. I would love to know that distance. That's what I'd really like to know. And then, once I'm done with that, I'd love to know the distance from the start to the second wall, whether it's the yellow distance or it's the whether it's the yellow or the purple distance. I'd like to know those two distances, wouldn't I? Because what would purple distance minus yellow distance actually give me? It would give me the distance between the two walls, wouldn't it? Or actually, let me reread the question. Show that the second wall be no less than this, no more than this from the first wall. Yeah, sorry. Actually, I digress. I actually want to know. See this green region? I'm hoping that turns out to be 23.52. And when I elongate the green region all the way back to the second wall, I'm hoping that answer is 70.56. That's what I'm after right now. That's what I'm hoping will happen. Here we go. First thing, get your SY. Everybody see the SY? Get that SY and turn its first answer is 14.7. You are going to do a minus B equation. You're going to find me the value of T. All right? So 4.9 T squared minus 19.6 T. I did it all in one go here. Plus 14.7 equals 0. And we're all doing a minus B equation. Don't delete the minus B formula either. We're going to use it again in a minute's time, okay? So once we get our two answers for T, let me know. Okay. Now, so look at this. So we got an answer of 1 and 3 seconds respectively. So follow my blue ball here, yeah? I fire it. That's 1 second in. It goes all the way over, and then on the way down, it hits the 14.7 again, 3 seconds in. But we're only after which one? What part of the question makes me only concerned with the first part? Upwards, pass. So I'm only concerned about the T equals 1. So what I know now, I know I have a bit of a lot of color going on here at the moment, but what I'm basically saying is it takes 1 second. There's a T value of 1 when it's 14.7 high. Yes. I'm not you. Okay, you heard it. Okay. The reason being is it gave me 2 times where the height is 14.7. So look, 14.7, 1 second in. All the way down, back down again. 14.7 for the second time, 3 seconds in. That's why there's 2 answers. Because it has to travel through a height of 14.7 twice. And we're only concerned with the way up, not the way down. I'll try and do the same thing. Does everybody see it? We're going to do the same thing for 18.375. However, this time, we're actually recognizing both times. Why am I recognizing both times? Because I'm concerned with it on the way up, and the way down. So here's what we're going to do. We're going to reuse what we did earlier. Instead of 14.7, what am I going to change that into? 18.375. And you're going to use the exact same minus b equation you used a second ago, except you're going to change 14.7 into 18.375. We're going to reuse our work, and we should be able to get 2 times out pretty quickly because you already have all the workings in your calculator. 3 over 2, so that's a t value of 1.5. That has to be on the way up, and then on the way down. 5 over 2 or 2.5, yeah? Now we're laughing. Now let me explain why we're laughing. Now, what's the SX equation? We had it a minute ago. Now get this, all right? Multiply that by 1, where t is 1. 47.04 times 1. What's the answer? So, do you know what that means? That means that this distance here, I'll get my highlighter out again. I'll make the pen a bit thinner this time. Okay. See this yellow, see that green distance I just put out? That's that one there. Now, to get the yellow distance from here to here, what do I need to do? Times 1.5. 70.56. Take the 2 of them away from each other to find the distance the wall has to be behind the first wall. 2 of them take away from each other. 30.52. I'm going to read the next question here. Yeah. Okay. And that's what the question wanted from us, wasn't it? 23.52 meters. Now, next thing we're going to do is going to sub in 2.5. 47.04 multiplied with 2.5. What do we get when we do that? Exactly. So multiply by 2.5, and what do we get? 100.6. Okay. Now, once again, take away that answer, take away 47.04. They're the 2 answers we're looking for. Your wall has to be situated somewhere between 23.52 or 70.56. Now, what happens if I make that wall closer? What happens? Huh? The ball won't clear it, will it? If I bring it all the way to the front, definitely not going to clear it, is it? And then, what happens if I move this further back? It'll hit the wall, won't it? But if I move it forward, it'll go over the wall, won't it?